Write the following as logarithmic equations, and I've already told you base 10. It's a bit of a strange question. We're just learning to rewrite things and using the log laws. It's just a skill we're practicing to be able to simplify future harder equations. So girls, basically all I want you to do is take the log of both sides, so it becomes log of y equals log of a cubed times b. And then I want us to expand it as much as we can. So it kind of looks like the ones down here. So break up whatever we can break up using our laws. Log of y, there's really nothing I can do there, so I'm just going to leave it as log of y. What's something I can do using my log laws to the right-hand side?
Log a cubed plus log a.
Beautiful. Now, guys, I'm going to just ask you for a second. Why couldn't I bring the 3 at the front before I did that step there? Why couldn't I go from here and say 3 log AB? The whole thing needs to be being cubed for me to move that 3 to the front. Excellent, girls. Okay, what's one more thing I can do? The last thing I can do, I'm just trying to use my laws to rewrite this thing. 3 log A plus log B. At the moment, you're like, well, what was the point of that? It's more about just practicing a skill. Okay, question B. Let's have a go. So I'm going to start the exact same way, which is log both sides. I'm literally just logging both sides. Log of y equals log of a on b squared. Now, I know you might like to go straight to the answer, but can we just do it one step at a time? What's my next line?
Log y equals log a minus log b squared.
Beautiful, that's correct. And what's the last one I can technically apply? 2 in the front of the log b. Can anyone start me off?
Log b equals log 10 minus log 10.
Yes, girls, is this, she did 2 steps in one, but is it correct? It is correct. You might have done just log of 10 over root n, but she also did the division, making it a minus. What can I do next? So log p stays as it is. Log of 10 is just 1, and then minus, what's something we could do? Yes?
It becomes log n to the power of a half.
Yes. And then what can we do? Put the half out the front. Excellent, girls. You're doing really well. Oh, with this next question, I kind of want to go backwards. Can I somehow get this back in kind of like this form? To do that, to get rid of the log, the only way I can get rid of log, girls, is if I have log of something equals log of something. Only then can I cancel out the logs by technically putting both to the power of 10, and only then does it cancel. So my first priority is to get it as 1 log equals to 1 log. So I want to combine the logs as much as I can. With that in mind, this side is already fine. Log of y, I'm just going to keep like that. What's the first step I can do on the right?
Log b cubed plus log c squared.
Take a moment, girls. Is she correct? But now I want it log of something equals log of something. What's that as 1 log? Like,
b cubed and c squared.
because it's timesing because of the plus, isn't it? It becomes times when you put them inside the same log. Excellent. Now what can we do? I'm happy for you to go cancel. Y equals b cubed c squared. I do want you to appreciate the reason we can do that is because I'm putting both equations to the power of 10. The 10 and the log cancel out, the 10 and the log cancel out, which is why it's just that left. B. Have a think about that one, and considering you did the previous question, you probably know what to do. What's my first step?
I made log x equal log a to the power of 5 minus log 10.
What do you think about the minus log 10? It's correct, because log of 10 is 1, and we need the log to bring the logs together. You know, I need it in log form. Is everyone okay? So then what happens in the next line? That was very good.
I did log and then in brackets a to the power of 5 over 10.
log of a to the 5 over 10, because the minus becomes division when you put it inside the log. What happens then? Cancel out the logs and I get? Fantastic. We have been working with log base 10, log base 10, log base 10. If I write log of x, you can assume it's base 10 if I don't include the 10. Do you agree? But here's another thing. There's a special base called e, a number called e, which has special properties in calculus and other topics which we have to work with as well. Now, the notation for that is ln x, which is log base e of x. Okay? E is a special number. It's approximately like 2.7 something. It's between 2 and 3. And if you put this number, 2.7 to the power of x, you get an exponential function like this one here. And its inverse is ln x, or log base e of x, which is the symmetrical along the line y equals x. So remember, e to the x and its inverse function ln x, they're inverses of each other, they cancel each other out. So remember, basically just like 10 to the x and log base 10, ln of e to the x, the ln and the e cancel each other out and you're just left with x. Similarly, e to the ln of x, the e and the ln cancel each other out and you're just left with x. Actually, look at your scientific calculator. Tell me, is there a button either that looks like e with a power, or is it ln? Ln. Do you have another one with e, like it's shift or separate? Shift. Okay, so ln is that button there, but for e to the power, press like e to a power, press shift ln, and then you should get e. Does that work? And then you can enter the number 1 to get e to the 1. So what do you get when you put that in there? 2.7-ish. Yep, 2.718. And so that's what it equals. E is about 2.718. Girls, remember how log base 10 of 10 equals 1? Similarly, log base e of e equals 1, or in other words, ln of e equals 1, which is there. Is that okay? Because ln, just assume it's log base e, always. Use your calculator to write the following in the form e to the x. 40 equals e to the ln 40. Do you agree? Why is that true? E and ln cancel out, right? But they said they want it in the form e to the x where x is a decimal. So what do I want to actually put in my calculator? ln 40. I want to know what ln 40 is as a decimal. So can you put ln 40 in your calculator? 3.6889. Well, I just wanted the power as a decimal. That's all they're asking for. How would I do the similar thing for 0.02? What's the first step? E to the ln 02. And so what do I then put in my calculator? Because ln 0.02, which is? 3.912. Oh, is that right? Does anyone agree? Great, and it's a negative, and that's absolutely correct. The reason it's a negative, girls, look at this graph. 0.02 would be somewhere in there, right? And if you go down to the ln function, it's a negative. Do you see that? When x is between 0 and 1 in here, it's down here, a negative. That's why it's negative. Anyway, find x if ln x equals 3.42. Girls, I just want to get rid of the ln. How do I cancel out ln? You put it to the power of e. I can put both sides to the power of e. They cancel out. And so x equals e to the 3.42. Does that make sense? Now, they wanted us to find x, so what do you think the last thing I need to do is? Put in the calculator, yeah. Can you put e to the 3.42 in your calculator? Now, given that they've given us no rounding instructions, how do I have to round? 3 significant figures is the minimum. What is that? 30.6. Thank you. All right, same thing for the next one. Put both sides to the power of e, the ln and the e cancel out, and x equals e to the negative 0.81, And what's that to 3 significant figures? Great. And that's it, and I'm going to stop there.